When you multiply fractions, you just simply multiply the top. So 25 times 14 is 350, and you multiply the bottom. 2 times 5 is 10. And as you can see, this will reduce actually to 35. Now, I typically don't do it this way because sometimes you might have a lot of reducing to do. What I do is I look, can things cancel if they're on a bottom to a top? So anything in a denominator can cancel with either numerator. Well, I see 2 will go into 14 seven times, and that leaves a 1 there. I see 5 will go into 25 5 times. 5 times 7, 35. And I get the same answer. I just get it faster if I'm having to actually reduce fractions. The big key with division, the only difference is you flip the second fraction. So in other words, that goes up there, that comes down there, and then I get 81 over 25, and that cannot be reduced. Okay, let's do some, please excuse my dear Aunt Sally, so I want to do the inside first. I can see that 2 would go into 8 4 times, so I end up with negative 5 over 12. When I'm dividing, I'm going to flip and multiply. And even from here, I can see I could divide out a 4 out of 12 and a 4 out of 16, 4 times 4. And a negative times a negative is a positive, so I get a positive 20 over 21. All right, when you're adding or subtracting fractions, they're pretty easy when the denominator is the same. You just carry the denominator and you just add the numerator. And then, of course, look to see if you can cancel any like terms. If they're not the same is when it's a little harder, and so you have to get a common denominator. One thing that will always work is just multiplying those two numbers together. It might mean you have to reduce later, but that will always work. So 5 times 9, 45, and 45. So what I do now is I look to see how did 5 become 45. I multiplied it by 9. Whatever you do to the bottom, you have to do the same thing to the top. So I'd multiply by 9. How did I get 9 to 45? I'd multiply by 5. So I multiply the top and the bottom, and I get 19 over 45, which cannot reduce. Now, another trick students kind of like to do to check this with your calculator is if you just put this straight in your calculator and you added 1/5 plus 2/9, you would get, most calculators give you decimals, 0.4222. Well, guess what if you put that in your calculator? You get the same answer. So it's just kind of a nice way to check your answers. All right, so the next one here, remember I said it always works if you multiply those. Oops, so 40 and 40. How did 10 get to 40? I had to multiply by 4, so I need to multiply this top by 4, so 36. How did 4 get to 40? Multiply by 10, top by 10. And now subtracting these, I get 26 over 40. And I can see that that would reduce because 2 times 13 and 2 times 20 would reduce to 13 over 20. Now, even though that always works, if you could find a least common denominator, it's a little faster. What I do is always look at the smallest denominator, and then I start thinking of multiples. You're going to have a number that's past this, 10. So 4 times 2 is 8, but 8's not past 10. 4 times 3 is 12, but 10 and 12 won't divide each other. So if I continue to do that, 4 times 4 is 16, 4 times 5 is 20. Both 10 and 4 will go into 20. How did 10 get to 20? Multiply by 2, need to multiply the top by 2. had 4 multiplied by 5. And now notice I get the answer right away without having to do any reducing. That's the biggest benefit of using least common denominators, is not having to reduce at the end.